Hello everyone. Today in this lecture we will study the important topic that is successive differentiation. Firstly, we shall study what is the meaning of successive differentiation. Like we are given a function, say y is equal to f of x, and it is asked that find its second order derivative, its third order derivative. These derivatives can easily be determined by using the methods studied in 10 plus 2. But if we are given to find the, say, 1000 times derivative of the simple algebraic function or simple trigonometric function, then it is really very difficult that how will you find 1000 derivative of y, where y is a simple algebraic function or it is simple trigonometric function. And if we are asked to find its derivative 1 lakh times, so it is really very tedious job by differentiating again and again and differentiating it 1 lakh times. So for our rescue it comes the successive differentiation. So now we will study the concept of successive differentiation. For that we will study the successive differentiation of simple functions. Like first function that we study is y is equal to x raised to the power m, and we are asked to find its nth order derivative, where n is less than m. So we will find its nth order derivative by simple generalization. We will differentiate it firstly, and we know its differentiation is m x raised to the power m minus 1. We will differentiate it again second times. It will be y2. This will come over here. It will be m minus 1 x raised to the power m minus 2. We will again differentiate y3 is equal to m minus 1. This will again come over here. So it will be x raised to the power m minus 3. Now we will try to find the value of yn by simple generalization. Look over here. When here is 1, so here is m minus 1. Here is 2, it is m minus 2. When here is 3, it is m minus 3. So whenever here will be yn, here will be x raised to the power m minus n. Fine. And when so this will be m minus 1 m minus 2, and it will continue up to 1 less than of n. So it will continue m minus 1 less of n. So this can be written as yn is equal to m minus 1 m minus 2 up to m minus n plus 1 x raised to the power m minus n. So this is the successive differentiation of x raised to the power m. And if n is equal to m, then ym in this case will be m minus 1, look over here, m minus 2 up to m minus m plus 1. Fine. And it will be m minus m. This will cancel out. So we are left with m minus 1 decreased by 1, m minus 2 decreased by 1. So at last it will be 1. and here will be 2 because it is decreased by 2, decreased by 1, so here will be 2. So this will be this one, and x raised to the power 0 is 1. So this is nothing but m factorial. So this is the second case when n is equal to m, and if n is less than m, in that case we have the nth order derivative as this one. But if n is greater than m, like we are given a function y is equal to x raised to the power 10, and we are required to find its 12th order derivative. Here 12 is greater than 10, so it will obviously be 0. For an example, again take y is equal to x square, and it is asked that find its third order derivative. Here 3 is greater than 2, so obviously this will have the third order derivative as 0. You could also do whatever you have done in plus 2. y1 of x square will be 2x, y2 will be 2, x is differentiation 1, and y3 of constant term is equal to 0. So this is the third case when n is greater than m. In that case y n will be 0, okay, where y is equal to x raised to the power m. So this is the third case. This is case number 3. This is second case, and this one is case number 1. So this is the successive differentiation of x raised to the power m, or the nth order derivative. This is written as nth order derivative of y is equal to x raised to the power m. So this is the first successive differentiation that we have studied. Now we will take the another successive differentiation. Now next problem is find nth order derivative of y is equal to ax plus b raised to the power m. So that is yn is equal to, we have to determine. Okay, so we will do it step by step by simple generalization. Differentiating it one time, we'll get m ax plus b raised to the power m minus 1 into a. Now once again differentiating, we'll get m minus 1 ax plus b raised to the power m minus 2 into, it will be a square. Now again differentiating, we'll do 2 or 3. Before generalization we at least have to do this at least 3 steps. So we are proceeding toward the third step, m minus 2 ax plus b raised to the power m minus 3 into a cube. Fine, and so on you can continue. In the end you will get yn. So see the generalization, when here is 2, here is 2, 3, here is 3, here is 2, here is 2, here is 1, here is 1. So whenever here is n, so here will be, you can write it as a raised to the power n. Similarly you see here is 1, so here is m minus 1, here is 2, here is m minus 2, here is 3, here is m minus 3. So whenever here will be n, ax plus b raised to the power m minus n. Fine. Now see how this series is running, these terms are running. Whenever here is 2, so here is m minus 0, m minus 1, 1 less than 2, 1 less than 3 up to 2. Okay, so it will be m minus 1, m minus 2. So it will run up to 1 less than n, that will be n minus 1. So this is further equal to m minus 1, m minus 2 and up to this will open up m minus n plus 1 into ax plus b raised to the power m minus n into a raised to the power n. This is yn, and here it is worth mentioning that n is less than m. What happens if n is equal to m? In this case, ym will be m minus 1, m minus 2, up to here will be m minus m plus 1. Okay, and it will be ax plus b raised to the power m minus m into a raised to the power m. So this will be further equal to m minus 1, m minus 2, up to this will cancel out, so we are left with here 1. So the terms are decreasing with 1, so if we have to write its preceding term, so it will be 2, then it will decrease by 1, it will become 1, so it will be something like into ax plus b raised to the power 0 is 1 into a raised to the power m. So by definition this is nothing but m factorial into a raised to the power m. So this is ym, which is a constant quantity. Okay, which is a constant quantity. So this is the nth order derivative of ax plus b raised to the power m. So now we will study the nth order derivative of one more simple type, and it is given by, this is the next problem, and in this we have to find nth order derivative of 1 by ax plus b. Let us suppose that this is assumed as 1 by ax plus b. Fine, and we have to find y of n, means its nth order derivative we have to determine. Now see, we will do it step by step. We know that y can be written as ax plus b raised to the power minus 1. Now differentiating it, first time this will be y1, minus 1 will come before this one, ax plus b, and this will become minus 1, and it will be a. So this is nothing but minus 1 ax plus b raised to the power minus 2 into a. Now differentiating one more time, it will be minus 1, minus 2, this will be ax plus b raised to the power minus 3 into a square. Now I am going to collect these two minus, so this can be written as minus 1 square, and this can be written as 1 into 2. Fine, and it will be ax plus b raised to the power minus 3 into a square. Fine, here is minus 1 raised to the power 1. So y3 will be, differentiate this thing so that we could generalize. Rather than differentiating this, we will differentiate this so that we could get the generalization. So this is minus 1, minus 2, minus 3 ax plus b minus 4 into a cube. Now I am going to collect these 3 minus, so this will be minus 1 cube, and it is written as 1 dot 2 dot 3, and it will be ax plus b raised to the power 4 into a cube. Now one more time, last time we are going to differentiate, then we will generalize. Differentiate this one so that we could generalize, because generalization means here is minus 1, here is minus 2, here is minus 3. One more time it will be minus 4, minus 1, minus 2, minus 3. It will be minus 4 ax plus b raised to the power minus 5 into a4 is equal to minus 1 raised to the power 4, 1, 2, 3, 4, and into ax plus b raised to the power minus 5 into a4. Now do the simple generalization yn. Look over here. When here is 4, it is minus 1 raised to the power 4. When here is 3, minus 1 raised to the power 3. When here is 2, minus 1 raised to the power 2. Here is 1, minus 1 raised to the power 1. So whenever here is n, so you can simply write it will be minus 1 raised to the power n. When here is 4, it is 1, 2, 3, 4. When here is 3, it is 1, 2, 3. When here will be n, it will be 1, 2, 3 up to n. Fine. When here is 4, it is 5, one more, and minus is before this. So it will be, when here will be n, so it will be minus n plus 1. When here is 4, here is 4, here is 3, here is 3. So whenever here will be n, so this will be an. So this can further be written as minus 1 raised to the power n. This can be written as n factorial, and this will go into denominator ax plus b raised to the power n plus 1 into an. So this is the nth order derivative of y is equal to 1 by ax plus b. So that is how we will find its nth order derivative. So that is all I have from this lecture, and in the next lecture we will take up some more simple functions and we will try to find their nth order derivative. So I hope that you will be able to understand the idea of nth order derivative, that why we were in requirement of these formulae that we have studied, because the simple differentiation studied up to 10 plus 2 is not enough to find the differentiation of simple functions up to 1 lakh times, up to 10,000 times. So for our rescue, it comes the successive differentiation. So I hope that you will be able to grasp the idea. Very soon I will be with you with my next video lecture, and you have to stay in touch, and for that you have to subscribe the channel and press the bell icon, so that whenever there is any lecture in future you will directly get the notification. So please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye. Take care. Bye bye. Stay healthy, stay fit. Thank you very much.